We're approaching T-minus 3 minutes, so let's leave it with mission control to follow the remainder of the countdown.
And Flo, this is flight on mission call. Please disable power package vac and confirm. To all operator, vehicle is ready. VMS is flight on mission call.
Go ahead.
You are go for auto sequence start at T-minus 2 minutes.
Auto sequence is locked.
Avionics, this is flight on mission call.
Flight avionics.
Please confirm all AV bats have been switched to internal power.
Confirm vehicles on internal power.
RCO, flight on mission call.
This RCO, go ahead.
Confirm ground power has been disabled on all 3 stages.
All stage bars down.
And to all operators, vehicle is on internal power.
Pressing locks.
PLS, flight on mission call.
Go ahead.
Please disable anti-geysering and confirm.
Pressing Kiro.
Confirmed disabled.
Stage 1, confirm stage 1 is pressed.
Stage 1 pressed.
Stage 2, confirm stage 2 is pressed.
Stage 2 is pressed.
AV battery checks. High flow engine purge active. Commanding deluge on. Deluge on. Readying GNC systems. Rereading engines.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
First motion. Stage 1 propulsion is nominal.
As you just saw, we've had successful liftoff of Rocket Lab's STP-27RD mission on That's a Funny Looking Cactus. The next major milestone we're coming up to is max Q, or maximum aerodynamic pressure.
Guidance is nominal.
This is where the forces on the vehicle are at their greatest during flight. So let's listen in.
Coming up on max Q. Max Q.
And there you have it. Electron has passed through max Q, or maximum aerodynamic pressure.
Stage 1 propulsion is nominal.
Coming up
Ágil
soon,
Essa
Electron will
testing.
go through a series of key mission milestones in relatively quick succession. Starting with main engine cutoff, or MECO, the 9 Rutherford engines on Electron's first stage will shut down in
30
preparation
seconds
for
remaining.
Stage 2 separation. Following this separation, we'll see ignition of the vacuum-optimized Rutherford engine on Electron's second stage.
Speed is 2 kilometers per second.
Entering burnout detect mode.
Five seconds remaining.
Stage 1 MECO.
Stage separation succeeded.
Stage 2 engine started.
As you can see, we have had MECO, or main engine cutoff. Electron's first and second stages have separated from each other, and the vacuum-optimized Rutherford engine on Electron's second stage will continue onto orbit. Very soon, we will see the fairing jettison and fall away from the vehicle. The fairing protects the payloads during ascent, but it isn't needed once we ascend to the thinner parts of the atmosphere.
Fairing separate.
And there it goes. Electron's fairing has been jettisoned to make way for payload deployment approximately 50 minutes from now. With the fairing gone, Electron continues towards orbit. Everything is looking great so far.
Guidance remains nominal.
This is Mission Control Auckland. Electron is performing as expected, and we're continuing on a nominal trajectory. Go Electron!
Stage 2 propulsion is nominal.
If you're just joining us, we've had successful launch of the STP-27RD mission aboard Electron. We've had stage separation, and Electron is continuing onto orbit. Mission Control Auckland checking in with you live during Electron's launch of the STP-27RD mission. As you can see, Stage 2 is continuing on its journey to orbit. Our next major milestone will be the battery hot swap. If you've watched our previous launches, you'll be familiar with this process, but if you're just joining us for the first time, here's what happens. Electron's Rutherford engines use electric pumps powered by lithium polymer batteries, but once these batteries are depleted, they're just dead weight. To overcome this, we perform a hot swap where we switch over power from the depleted batteries to a fully charged one, providing a more efficient ride to orbit. So look out for the battery jettison shortly.
Vehicles to the safe gate.
AFTS is safe.
HV battery hot swap. HV battery eject.
Stage 2 propulsion nominal.
As you can see, we've had successful hot swap and jettison of the depleted batteries. Stage 2 propulsion is nominal, and our trajectory is looking good.
One 100 seconds remaining. Speed is 5.5 kilometers per second. Altitude is 198 kilometers.
Just a bit of a recap for the launch of the STP-27RD mission on Electron. We've had successful ignition, stage 1 burn, and stage separation, and we're now following stage 2 as it continues onto orbit, transporting 3 satellites for
During
the
stage
space
2
test
burnout
program.
detect mode.
This burn will continue until around T+9 minutes, and then our kick stage will separate. So we've got about 1 minute left before stage 2 engine shutdown.
Thirty seconds remaining. Ten seconds remaining.
Engine shut down.
Transfer orbit looks good.
Confirm stage 3 separation.
And with that call, we can confirm that the kick stage has separated from Electron's second stage. As we mentioned earlier, we won't be receiving video of today's payload's deployment, so we've prepared a short video illustrating this process. At approximately T+54 minutes, the 3 satellites on today's mission will be deployed to precise, predefined orbits in quick succession. So stay tuned to our social media channels for confirmation of this payload deployment. So with that, we're going to end today's webcast. A huge thanks to the U.S. Air Force, their space test program, and our mission partners for choosing to launch on Electron. Thank you also to the FAA and the New Zealand Space Agency for licensing this launch. The entire Rocket Lab team would like to thank you for joining us for our 6th Electron launch, and we look forward to seeing you guys again soon. This is Rocket Lab Mission Control signing off.